So we've got the basics of the beginning of describing electrons using quantum numbers, right? N being the principal quantum number, L being the angular momentum quantum number, M being a magnetic number or magnetic quantum number. This describes basic energy of the shell, followed by the number of nodes in each one of the orbitals, and then the directions that we've got. The last magnetic descriptor is the magnetic spin quantum number, and it's labeled as MS. And what it means is that the electron is either going to have a spin, either plus 1/2 or minus 1/2. That's it. Can't be anything else. So there's nothing to really compare it to. This one here is the basic, and the L is derived from the N, and then the M is derived from the L. This is not derived from any of that. It just tells us what the spin of the electron is. It will either be plus 1/2 or minus 1/2. That's it. This tells us that the electrons inside each one of the orbital directions is as a maximum of 2. I can only have 2 electrons within each one of those directions. Okay? So to essentially state that, if I have something that's just an s orbital, okay, so here's our s orbital, I can have 2 electrons maximum within this shell. The reason being is that I can either have a plus 1/2 or a minus 1/2 electron inside of that sphere. That's all I can have. Okay? All right. So that's the basics of what these things are. All right? So to put them into sort of a descriptive shape, what I'm going to do is I'm going to list them. I'm going to say we've got N, and I've got L, right? And I've got M, and here's MS. Okay? So if I start with an N value of 1, the only possible L's that I can have are 0, right? And then that's it. So that means that the shell that I can use in that case, or the orbital, is going to be called an s orbital. All right? So what's M going to be? M is going to be 0, which means there's only one direction for this thing, and that's that big spherical shape. So if M is 0, okay, this tells us that there's only one shape of this. There's 0 nodes. So my MS can either be plus 1/2 or minus 1/2. Okay? I'm going to use this and describe this as kind of a GPS coordinate of this particular electron. Okay? One of the electrons has the GPS coordinates of 1, 0, 0, 1/2, or plus 1/2. That coordinate tells us that there's one electron that can hold that particular set of quantum numbers. I can't have more than one electron, which describes that. It's kind of like saying a GPS location. I look at the GPS location, it's my house. I can't have another house within my house. Okay? That would just be weird. No GPS coordinates will do that. They won't land 2 things on their house if they're working properly, right? So the other GPS coordinate, the other electron, is going to be 1, 0, 0, minus 1/2. Okay? And that tells us a lot about that particular electron, where it is. Okay? Now, if I go to quantum number, or principal quantum number 2, what are my L values going to be? I can have a 1, or I can have a 0. If I have a 0, the shell descriptor, or the orbital descriptor, is going to be S, and this one is going to be P. All right? So what's the M value for the S? The M value is going to be 0 for this one, which means I'm going to have a plus 1/2 and a minus 1/2 for that shell. Okay? And for P, I'm going to have minus 1, 0, plus 1, or plus 1, 0, minus 1, however you want to write it. Okay? Now, the important thing to know about this is that my magnetic spin quantum numbers, the 2 electrons that are within that value, okay, each one of these is going to have 2 electrons. So the minus 1 has a minus 1/2 and a plus 1/2. The 0 has a minus or a plus 1/2 and a minus 1/2. The plus 1 has the same thing. Okay? What this tells us is that there's 2 electrons in each one of those orbital directions. Okay, so inside of the S, how many maximum electrons do you think I'm going to have? 2 electrons. Each one of these spin numbers tells us I've got a maximum of 2 electrons that I can have in there. Okay? So this means, S means I've got 2 electrons total in there. For the P, I can have 2, 4, 6 electrons inside the P. And down here, I've got 2 electrons as well. Okay? Now, when I come to quantum number 3, okay, I'm going to have the same. I'm going to have 2, 1, and 0 as my azimuthal or angular momentum quantum numbers. All right. When I get to this descriptor of this particular orbital, that's D. So now I've got D, P, and S. And notice that S doesn't really change. What's the M for these values? 0. This is going to be plus 1, 0, minus 1. And this one, guess what? You're right. It's going to be that. Okay? And the MS, I've still got 2 electrons that are built within that. Okay? So let's give an example of what one of these D electrons is going to look like. Okay? So if I have 3, okay, that's going to be my principal quantum number. Second number is 2. My third number can be minus 1, and then plus 1/2. Okay? That's one of the electrons that can go in this particular orbital. Okay, this direction of this lobe of this orbital. Okay? It can also be a minus 1 here. So 2 maximum electrons. So how many electrons are going to be in the D shell? You said 10. You are cooking with gas. So this is 10 electrons. Okay? Because I've got 2, 4, 6, 8, 10 total electrons that can be in the D. Okay, I'm not going to draw them all out. Now what about for 4 here? Alright, I'm just going to show you what 3 is. Because 3 is our F orbital. And how many electrons total can I have in there? Well, 3, 2, 1, 0, minus 1, minus 2, minus 3. 2 electrons for each one of those directions. I've got 7 directions, so I'm going to have 14 electrons built within that. Okay? Alright, so all of these things tell us basically a GPS coordinate of each one of the electrons. And now this is great, but now we want to build up each one of our orbitals and give them a configuration for all the electrons that are available in a very simple way. Alright? Alright, and I'm going to start with the basics. I'm going to start with hydrogen. Hydrogen only has 1 electron. So what is going to be our GPS coordinate for this? Well, we look at the lowest energy that exists because we want to assign everything by their lowest or ground state energies. Okay, so I'm going to start this where n is equal to 1. Okay, that means L is equal to 0. What's M going to be? M is going to be 0. All right, and what is the MS going to be? That's going to be plus 1/2 or minus 1/2. I'll say plus because everybody likes to start with plus. Right? So that gives us the coordinates of that particular first electron. Now when I go to helium, helium now has 2 electrons. Alright? I'm going to say that the first electron that helium had is exactly the same as the hydrogen. Okay? Because that's the first electron. Now we're throwing in the second electron. The second electron is going to have almost the same address. The only difference at this point is that this is minus 1/2. And at this point, because I've got a plus 1/2 and a minus 1/2 electron, the shell, or this direction, the 0 direction here, is now full of electrons. Okay? Remember that this is the s orbital. So at this point, my s orbital is full. Okay, the s orbital is full at that point. Okay. So what does this mean consequentially? If I go to lithium, which is next, and that's got 3 electrons, I'm going to assign each one of those electrons to be the first electrons of lithium. But then we look at lithium and we say, well, we can't put any more electrons in there. So what are we going to do? We have to go to an outer shell. So now at this point, N is equal to 2. All right. I have 2 possibilities here. L can be equal to 1 or L can be equal to 0. Remember, lower is lowest energy. So what's going to be the low energy at this point? 0. That's right. So the L is going to be 0 there. M is going to be 0. And MS is either going to be plus 1/2 or minus 1/2. Right. When I look at that coordinate, what does that tell me about the shell that's being fulfilled first? That's right, it's an S. Okay? So what that means is that for lithium, the first thing I had to do was fill my 1s with 2 electrons. Now I have to fill my 2s with electrons as well. Okay? Lithium doesn't fill up those electrons because all it's got is 3 electrons. Okay, now I'm going to jump a little bit. I'm going to go to carbon. Carbon has 6 electrons. Okay? The N value for this is going to be what? 2, that's right. Good. And now I've got L that's 0, but that was filled earlier with my 3rd and 4th electrons. So I can't use 0 here because that's already full. So what I'm going to do is have L equal to 1. That means I'm going to start populating the M plus 1, the M 0, and the M minus 1. Okay. So at this point we start putting plus 1/2 or minus 1/2 inside of each one of these. And generally people look at this and say, all right, well I'm going to do plus 1 here, or plus 1/2, and then minus 1/2, and then fill that up. It's not how it works. Okay, think about it this way. If I have 2 electrons, they're both negatively charged, I try to squeeze them in the same spot, what's going to happen? That's right, they're going to repel each other. And if they repel each other, that's a problem. Okay? It's easier to put the other electron this way. Think about it this way. You're in a college dormitory, okay? And you're the RA and you start filling the dorm rooms. What are you going to do first? Are you going to take 2 people and stick them in a dorm room and leave the other ones empty? What's the probability of those 2 people fighting over a certain amount of time? At a certain time, they're going to start fighting, right? That's an issue. So rather than worry about them fighting, you're going to take 1 person from that room and then move them over to an empty room. It's the same general principle here. Okay? We start filling in electrons, and we don't pair electrons until we have to. Okay? All right, now we want to show you, there's some rules that are associated with this. Okay? And there's the Pauli exclusion principle. Okay, Pauli exclusion principle. And what the Pauli exclusion principle states is that you can't have 2 electrons with the same quantum number set. Okay? It's the GPS coordinate rule. You can't have 2 things falling on the same location. So Pauli's exclusion principle states that you can't have 2 sets of identical quantum numbers. All right, you can't have 2 sets of identical quantum numbers. All right. The Aufbau principle. The Aufbau principle. All right. All exclusion here. The Aufbau principle, what that states is that we always start filling up from the lowest energy first. Okay? Fill energy low to high. It's like having an empty glass and you pour water into it. Where does the water go first? Does it stick at the top and then slowly start diffusing into the glass? No. It goes to the bottom and fills from the top. Okay? So Aufbau principle. go from lowest energy up to highest energy. Finally, there's the Hund's rule. All right? And Hund's rule, when applied, simply states that we don't